Let me paint you a picture. It's October 15th, 2024, Lenovo Tech World. One of the fiercest competitors in the history of the semiconductor industry, Intel and AMD, are on the same stage in the same room, announcing something together. Lisa Su and Pat Gelsinger side by side. That's not something you just stumble across on a Tuesday. That's a moment. And I think a lot of people scrolled past it without realizing what it actually meant. These two companies have been going at each other's throats since 1970s. We're talking over 50 years of brutal competition. AMD started out as a second source manufacturer of Intel chips and then grew into a full-on rival that at various points embarrassed Intel so badly that the blue team had to officially completely rethink the processor roadmap. And now they're collaborating officially with a press release and everything. So what actually happened? And more importantly, why should you care? Because I genuinely think this is one of the most underrated tech stories of the past couple of years, and I want to break it all down for you right now. So here's the deal. On October 15th, 2024, Intel and AMD jointly announced the creation of x86 Ecosystem Advisory Group, or the EAG for short. This is a formal initiative where both companies, along with a massive list of industry heavyweights, commit to shaping the future of x86 computing together, not separately, together. The founding members list is genuinely stacking. We're talking Broadcom, Dell, Google, Hewlett-Packard Enterprise, HP Inc., Lenovo, Meta, Microsoft, Oracle, and Red Hat. That's basically a who's who of the enterprise and consumer tech world, all agreeing to sit at the same table. But what makes this even more interesting is that two luminaries they brought in, Linus Torvald, the creator of Linux, and Tim Sweeney, the founder of Epic Games. Linus represents the open source and enterprise OS world. Tim Sweeney represents gaming and one of the most widely used game engines on this planet, Unreal Engine. Those two names alone tell you the scope of what this group is trying to cover, from supercomputers all the way down to handheld gaming devices. Now, the mission statement is pretty clear: enhance capability, predictability, and consistency across x86 processor-based products. In plain English, they want x86 to stop being a fragmented mess and start behaving like a unified platform. Now, here's where it gets really interesting, and where I think the business and engineering logic behind this move starts to make a lot more sense. x86 has a fragmentation problem, a pretty serious one. The best example is the AVX512, a set of advanced vector instructions. Intel introduced AVX512 back in 2013, and 11 years later, the implementation across both Intel's own product stack and AMD's lineup was widely inconsistent. Some chips had it, some didn't, some had partial versions of it, and because of that inconsistency, developers and software companies largely refused to build serious optimization software around it because they couldn't predict what hardware it would actually run on. That is a massive waste of potential, and x86 has been bleeding market share to the ARM and RISC-V. Partly because those architectures offer cleaner, more predictable developer experiences. ARM especially has made huge gains in mobile, in Apple Silicon, and increasingly in data centers. RISC-V is growing fast in embedded and edge computing. Intel and AMD looked at this situation and apparently both came to the same conclusion. If they keep fighting each other while the house burns down, they both lose. Better to standardize the platform and compete on top of it rather than fight about the foundation. And look, these two companies have actually collaborated before, even as competitors. They worked together on PCI, PCIe, ACPI, and USB standards, so the precedent exists. This advisory group just takes the collaboration to a much more deliberate and formalized level. Now, the anniversary update came in October 2025, and AMD published a blog post detailing what the EAG actually accomplished in its first year, and I have to say, this is where things get technically meaty and genuinely exciting. First up, FRED, which stands for Flexible Return and Event Delivery. This got finalized as a standard feature. FRED modernizes how x86 handles interrupts, which are basically signals that tell processors to stop what it's doing and handle something more urgent. The old interrupt model on the x86 was ancient and had accumulated a lot of technical debt over the decades. FRED introduced a cleaner system that reduces latency and improves reliability for system software. This matters most for operating systems and hypervisors, so it's not something you'll see on a benchmark chart, but it's the kind of foundation work that makes everything else run better. Second, AVX10 got established as the next generation vector and general purpose instruction set extension. This is the direct successor to the fragmented AVX512 mess I mentioned earlier. AVX10 is designed to boost processing throughput while actually being portable across client, workstation, and server CPUs. That's the key word right there. Portable. They're specifically trying to fix the problem where developers couldn't rely on instruction set availability. If AVX10 lands consistently across the lineup, software engineers can actually build around it with confidence. Third, and this one is probably the most impactful for everyday users and security professionals, ChkTag. This is a unified memory tagging specification that the EAG introduced to combat memory safety vulnerabilities. Buffer overflows, use after free errors, these are among the oldest and most exploited categories of software vulnerabilities. We're talking about bugs that have been causing security breaches for literally decades. ChkTag adds hardware instructions to detect these violations at the processor level. And here's the smart part. Software that uses ChkTag remains compatible with processors that don't have hardware to support it, so developers can write code for it now without waiting for every user to upgrade. The full ChkTag specification was expected to drop by the end of 2025. Fourth, ACE, or Advanced Matrix Extensions for Matrix Multiplication, got accepted and implemented across the stack. This one is very clearly an AI-era feature. Matrix multiplication is the core of almost every neural network workload, and by standardizing how x86 handles it from laptops all the way to data center servers, developers building AI applications get consistent targets to optimize for. That's a big deal as AI inference moves increasingly to edge devices. Okay, so here's my take on all of this, and I want to be straightforward. I find this genuinely exciting, and I think that the skeptics who dismissed it as just a PR move are missing the bigger picture. What Intel and AMD are building here is, in effect, a defense of the x86 and the dominant computer architecture for the next several decades. And I think that defense is a smart and necessary move. ARM isn't slowing down. Apple proved with the M-series chips that you can build world-class performance on a non-x86 foundation. Qualcomm is pushing hard into Windows laptops with ARM chips. RISC-V is becoming a real option for a growing number of use cases. The x86 camp needs to get its act together, and the EAG is a real, concrete attempt to do it. The technical deliverables from the first year are not just on paper. FRED, AVX10, ChkTag, and ACE are real architectural commitments with real implications for developers and end users. Memory safety through ChkTag alone could prevent a category of vulnerabilities that has been plaguing computing for 50 years. If that rolls out consistently, that's genuinely significant. I love the symbolism of Linus Torvalds being in the room. Linux runs essentially everything in the data center world. Having the guy who created it directly involved in shaping x86's future means that this isn't just a corporate agreement. It has buy-in from actual people who built the software that runs on these chips. Is it a little weird that two of the most competitive companies in the history are suddenly best friends? Yeah, sure. But I think that weirdness is exactly what makes this story worth paying attention to. When the two biggest x86 vendors decide that the platform itself is more important than their individual rivalry, something has genuinely shifted. And for anyone who builds an x86, develops software for it, or just uses a PC or server that runs on it, that shift is a good thing. The x86 Ecosystem Advisory Group just turned 1 year old, and honestly, based on what they delivered in 1 year, I'm genuinely curious to see what year 2 looks like. Looking ahead, the EAG has laid out its priorities for the second year. They're planning to add a new strategic ISV partner, which means more independent software vendors getting a seat at the table and feeding real-world developer needs back into the architecture decisions. They're also going to evaluate the new ISA extensions that offer demonstrable advantages to customers, and they're focused on reinforcing the long-term stability and predictability of x86 as a platform. That last point is subtle, but very important. Predictability is what enterprise customers and developers need most. They need to know that if they optimize software for a specific set of features today, that investment will still pay off 3 or 5 years from now. That kind of stability is something the old fragmented approach couldn't guarantee. If the EAG pulls it off, x86 gets a second wind that could just keep it relevant well into the 2030s and maybe even beyond. 50 years in, and x86 might just be getting started.